this segment of ALEKS College Algebra, we will be looking at graphing a parabola which is in the form y equals ax squared. And so before we head into this one, let me tell you a couple things here. It is very useful if we basically memorize what is going on here with what I call the basic parabola, or the parabola here where a is equal to 1. And of course, if a is equal to 1 here, this will simply be y equals x squared. This is a very fundamental and important graph that everybody should know, and everything that we do after this will basically be playing off of this particular shape anyway. So what we really need to do here is to understand what's going on with this graph. Now typically what we will do here is plot these 5 points. So let's try at -2. Well, -2 is going to be replaced then in place of x here, so -2 squared is 4. -1. Well, -1 squared is 1. 0 squared is 0. 1 squared is 1, and notice what's happened now is that the graph has been coming down, coming down, coming down to 0, and now it's turned and it started back up. This important point right here is called the vertex of the graph, because that is the turning point. So if we make a graph of this, we're going to have this 0, 0 point right here. Notice then, as we go to the right, we will go with an x of 1 and a y of 1. So I will say over 1 up 1, and then over 2 up 4. So this will be the point 1, 1. This will be the point 2, 4. So over 1, up 1, over 2, up 4. Now notice that on the left-hand side of the graph we have exactly the same thing happening, because as you go 1 to the left you will go 1 up. And so we will have this symmetric condition, same on both sides, as we say. And as we go 2 left, we will go 4 up. Once again, we'll have this symmetry, and so we will get this kind of a curved shape here that is called a parabola. Okay, and it's the most basic parabola shape ever. Now, what we will do then is to put a number in front of this x squared that's not 1 in a typical situation. So we'll go back to situations up in here, and we're going to put numbers in there. Let's refer to my notes on this as well, because in this section of my notes right here, we talk about multiplying a function by a constant like a. So this is like a f of x. In our case, the f of x function is the x squared function, but this is true of other functions as well, not just the parabola x squared, but it's a particularly good example. Okay, so if you have the situation of a times f of x, which is what we're going to have here, a times the x squared, let's look at that. We can see that the effect of that is basically going to cause what we call a vertical stretching, but notice that the a number, that number in front, has to be greater than 1 if we stretch. Otherwise, if that number is between 0 and 1, in other words a fraction, it's going to cause that to shrink. It's going to cause that number to actually be shrunk down, or to be compressed in the vertical direction. So stretched and compressed might be another way to say that. So let's look at that particular transformation, that stretching and shrinking, or stretching and compressing in the vertical direction. Let's apply that to a real problem here in ALEKS, and notice that we have the 1/2. Now notice that that number is in fact going to be between 0 and 1, so this is going to be a shrink, a compression. So oftentimes what I think here, kind of what I think about, is think about taking this basic parabola shape and basically drawing this or scratching this on the side of a block of clay, and then compressing that block of clay. What that will do is that will crush this vertical dimension and essentially make this graph appear wider in this area. Now, of course, the reason that it does that is because we are going to multiply each of our y values by 1/2. So we can look back over here at our graph, or our chart rather, and see that what's going to happen here is that we're going to take these values, but each of those then is going to be divided by 2. So what's going to happen here then is that we will have this negative 2 squared gives 4, but then we will divide that by 2, and we will get a 2 here. And then 1 divided by 2 turns out to be a 1/2, and then a 0, and then a 1/2, and then a 2 again down here. So we're going to have this effect of dividing this vertical displacement by 2, which essentially is crushing or compressing in the vertical direction, or shrinking, as we say. And let's go ahead and take a look at that then over here in the ALEKS graph. Once again, one thing we can be sure of is that the point 0, 0, the vertex remains the same. Now, as we go over 1, formerly, remember, we went up 1, but we won't now. We'll go over 1 and up a half. We'll go over 2. We normally would go up 4, but now we go over 2 and up 2. And of course, on the other side of the graph, we do the same thing because of symmetry. So we have a point here at -1 up a half, -2 up 2. And so we have our 5 points on our graph. Once again, this is going to give us this compressed effect. Let's check it. Before we do that, let's go ahead and draw the graph. This function here connects the dots and makes our graph for us. And notice this makes the parabola that we want. And then let's check it. Okay, let's do another one of those. Let's see if we can get a different one here. Okay, now we're going to get a couple of different things going on, because notice we're going to have the 3/4 number here, but we've also got a negative going on. We're going to multiply by a -3/4. In fact, what I might as well do now is introduce this next transformation to you. Let's once again go back over here and take a look at our notes. This is going to be covered under the reflection category. Notice if we have a negative in front of our function here, what that's going to do is to cause this graph to reflect across the x-axis. It's going to flip the parabola upside down. Okay, so we're going to do a couple things. We're going to flip the graph upside down in our particular case here, and then furthermore, we're going to kind of crush it, because you see here we have this 3/4 value. Now our normal parabola, let's tell you once again what normal is like. So we're going to have a normal situation with a vertex at 0, 0. We're going to go over 1, up 1, over 1, up 1 in both sides, over 2, up 4, over 2, up 4. This is our normal situation, which we're not going to have, but that's what our normal graph would look like. Our graph, though, is going to be flipped upside down because of the negative. We're multiplying by a negative number, and then we're going to also have this compression effect, because it's only going to be 3/4. So let's go ahead and run a few of those numbers. Once again, the vertex remains unchanged, but instead of going over 1 and up 1, we're going to go over 1 and down. This says down 3/4. So we're going to have the point. In fact, we're going to have to plot that here. We're going to have 1, and then we're going to have the point negative, and then we're going to have 3/4. So we're going to have that value, and let's plot it. Okay, we're going to go over 2. A normal thing is over 2 and up 4, but we're not going to. We're going to go over 2, and then we're going to go down 3/4 of 4, in other words 3. So we're going to grab our pencil, go over 2 and down 3, right to there. Of course, there's going to be exact symmetry points here on both sides, so we're going to go left 1, down 3/4. So I might have to plot that here. So let's see how this works. Okay, and of course we're going to have -2. Normally we go -2 up 4, but now it's going to be -2 and down 3, because we're going to go 3/4 of 4 in the negative direction. So we're going to grab our pencil and plot that symmetry point there. And while we're at it here, I'm going to have to get rid of this top one now. So let's get rid of those points. Okay, get rid of those. And that's the graph that they want. Let's go ahead and check that. Okay, you think we're good on that one? Let's say that this is graphing the parabola y equals ax squared in ALEKS College Algebra.